All right, students, for this next system, I want to look at solving this one by graphing and using technology. So when we solve by graphing, even if we're graphing by hand or with technology, what we're looking to do is to make both, we're looking for where our graphs intersect. So graphing with technology or by hand, we want to graph each equation and find the point or points of intersection. So let's look at our two equations here. If I'm going to graph this by hand, then I can just look for points that make this equation true. So I can see that right now. Let me move into another page again. Okay, so now we're going to look at example C. So we had x plus 2y is 1, and y is a half x, negative a half x plus 4. Negative a half x plus 4. So if I was going to graph this one by hand, then I'm looking for points that make this true. If x is 1 and y is 0, that makes this equation true. If x is negative 1 and y is 1, that also makes this equation true. And I could continue doing that, looking for points where it goes through. If y was 2, 2 times 2 is 4, so then x would be negative 3. So negative 3, 2 would also be a point. But quite often, graphing by hand isn't going to be as accurate, especially if our solution has decimals. So let's look at how we can graph it with our calculator. This equation is super easy for us to graph either by hand or with our calculator because we know that it has a y-intercept of 4. That, of course, means it goes through the point 0, 4. And a slope of negative a half, so it goes down 1 and to the right 2. But if I'm just going to sketch it, especially here without grid paper, this is going to end up not being very accurate. I've got the point 1, 0, negative 1, 1, negative 3, 2, and clearly I haven't scaled very well, but that would be my first line, something like that. My next line, y-intercept of 4. 4 is going to be up here, down 1, and then over 2 is going to look something like this. Oh, and it looks like these lines might not ever meet. So let's test it out and look at it on our calculator. So in my calculator, I'm going to go to y equals. For this first line, notice it's y equals, so I have to get the y by itself. That means in this first equation, we have to isolate the y. So I'm going to put in yet another page. So I had x plus 2y equals 1. Subtract x to both sides. 2y is negative x plus 1. And I put the negative 1 in there just to remind me that there is a coefficient in front of the x. Divide everything by 2, negative a half x plus a half. And now if I look at my second equation was negative a half x plus 4. Well, right now, these lines have the same slope and different y-intercepts. I know straight away that they are parallel because they have the same slopes, they have different y-intercepts. They are never going to intersect. So there is no solution because there is no point of intersection. So I don't even need to use my calculator to verify this at this point because I can verify it logically to myself. So I'm going to stop here and we'll use our calculator another time.